Okay, student, let us see what is there in this question. A loudspeaker emits sound waves of frequency f towards a metal plate that reflects the waves. A small microphone is moved along the line from the metal plate to the loudspeaker. The intensity of the sound detected at the microphone as it moves varies regularly between maximum and the minimum value. The speed of the sound in the air is 340. First question, explain the variation in the intensity. So, why? What is happening here? First of all, try to understand what this question wants to say. In IB, like in paper two questions, the first important thing is to understand what is the statement. Because in many of the questions, even statement is not clear what they are actually giving, what is actually given there. Okay. So first of all, this is not moving. The speaker is not moving. It is stationary and it is emitting the sound here. So this sound is going towards this, and obviously at this point it is going to be reflected, and then the wave is coming back to the speaker. Now, the condition for the standing wave is that it is the superposition of two waves which are having same wavelength, same frequency, same amplitude, everything same, but only that they're moving in different directions. So actually, it is this overlap of reflected wave. So this is the wave number one. You can say this is the first wave, and when it is getting reflected, let us call it the second wave. Both of them are superposing. Clearly, standing waves are becoming like they are created here. So standing wave will be somewhat like this. So when this is the detector, it is moving like from the point A to B all across this distance. So it is moving from A to B. So it is first saying that yes, the amplitude is very high, then it becomes zero, then it becomes maximum, then it becomes zero after exact intervals, after the same intervals. And now the question is, explain the variation in the intensity. Obviously, this everything has to be written there, that the wave which is given by loudspeaker, that is getting reflected from the metal plate. Both of the waves, they will be overlapping each other. That will give rise to the standing wave, and that is why we are having nodes and anti-nodes throughout, like distributed throughout the space. So while the microphone is moving from the loudspeaker to the metal plate, it is detecting all the nodes and anti-nodes alternatively. This is what is the explanation. We will see the mark scheme later. Let us move to the next question. Adjacent minima are separated by a distance of 0.12 meter. Calculate frequency. So in the case of sound standing waves, we know that the distance between two nodes or two antinodes is always equal to lambda by 2, and that is given by 0.12 according to them. So it is 0.12 meters. Accordingly, the wavelength can be found to be 0.24 meter, and you can find the frequency because the speed is given. So speed is equal to lambda into f, sorry, f. So wavelength is 0.24, frequency we want to find, and the speed is 340. So accordingly we can 340 divided by 0.24. Yes, the answer is 1416 something. So overall we can say that it will be, well, the answer should be in the two significant figures, but that is not given here. Okay, let me verify the units and then this will be the answer. Yeah, 0.12 meters. Yes, so this will going to be the answer, 1416 or 17 hertz. This will be our answer. Let's see what they have given in the mark scheme. Yes. So in this case, in second question, the wavelength is coming out to be 0.24, exactly what we did. 340 divided by 0.24, which they can call it 1.4 kilohertz. Yes, because we were interested in two significant figures. So you can uh, give the answer in this, or you can just call it 1400 hertz. Because of the significant figures, the IB prefers the answers with two significant figures. I have seen it. So accordingly you would be having answer in 2. So this is how we do it. And what about the first question? Incident wave superpose the that leads the standing wave, nodes and antinodes are present. Okay, anything like you know what to write here now. Let us move to the next question. The metal plate is replaced by a wooden plate that reflects a lower intensity sound wave than the metal plate. State and explain the differences between the sound intensities detected by the same microphone with the metal plate and the wooden plate. Well, exactly. Yes. Let me explain you this question now. Well, while I was telling you like what is happening, I gave you the definition for the standing wave. And I told you that it is the superposition of two waves which have the same frequency, they have the same wavelength. And I said that they must be having the same amplitude also. Intensity and amplitude is related like this. Intensity is directly proportional to a square. So whether you call it intensity or you call it amplitude, one is the same thing, isn't it? Like from the differences point of view. So when you are using a wooden plate, what is happening? When the wave is getting reflected, the amplitude is reducing. It means intensity is reducing. So in this case, the amplitude is not constant. So will the standing wave be formed? Well, yes. The answer is yes. The standing waves will be formed. But what will happen now? So the peak value that earlier it was coming out to be like a1 plus a2 and it was coming out to be 2a, but now it will be a1 plus a2, which will be lesser than 2a, because this other way which is coming is having lesser amplitude. But at the node, like this is at antinode. What about the nodes? At the nodes the intensity was supposed to be a minus a, that is 0. But in this case, it is not going to be 0. It will be a1 minus a2. A2 will be lesser than a1. Hence, this value will be greater than 0. It means in this standing wave, the nodes will not be having 0 amplitude or the 0 intensity. They will not be 100% a node. But yes, the volume will be very, very less, and it will not vary with respect to time. But on the position of the antinode, the amplitude will reduce, but it will still vary. Okay, so this is what we have to write in this question. Let's see the mark scheme. Relates to the intensity of the amplitude, antinodes will be decreased, the maximum intensity will decrease, and the nodes, the minimum will increase. It means it will become louder, hence the intensity at the nodes will no longer be 0. Difference in intensity will be less. Maxima and minima are at the same positions. Positions will not vary because that depends upon the wavelength and frequency. So position will not change, but these things will change. Okay, is it over? Yes. So here the question is completed. Thanks for watching. This is Professor Varun. All the best. Bye. See you in the next video.